Hello, so I'm Carlos, this is Leandro. We are both software engineers at Linaro working on LLVM development. And today we're going to talk to you about the stage of Flang development. So first things first, for those who are not familiar with this, Flang's the new LLVM Fortran frontend. So there's a bit of confusion because there was another compiler called Flang before, which is the open source version of the PGI Fortran compiler, which we will refer to as classic Flang. So from now on, when we say Flang, it's the new Flang. So the new Flang is new frontend. It's written in C++ from scratch, and it's a typical LLVM-based compiler. So in the sense that will generate LLVM IR. So, but it's a bit different from Clang because in Clang you go from the AST to LLVM IR, and on Flang we have what we call the high-level Fortran IR, which we'll call AGL FIR. So from the parse tree we'll lower to MLIR. Oh, sorry, and AGL FIR is based on the MLIR infrastructure. So from there we'll lower to from the parse tree we'll lower to MLIR, then use FIR, AGL FIR, and other MLIR dialects, and then convert that to LLVM IR, then to machine code. And currently, this frontend supports Fortran 9.5, which is mostly done. There are a few corner cases here and there, but it's practically complete. For Fortran 2003, we have most of the work completed. I think the biggest issue now is to complete the procedure points of support. And for the newer standards from 2008 and beyond, that's not really in development. Like, we have a few features supported. Some of the features can be parsed by the front end, but you will hit an error when you try to compile a program, and like a to-do error message that will abort the compilation. And now the other will talk a bit about GPU target offloading.
Hello. So I would like to talk a bit about other areas of Flang and how its support is going. And I would like to begin with target offloading. That is basically the transfer of compute-intensive tasks to other devices, such as GPUs. And some highlights in this area are the CUDA Fortran support that was added recently. And there were also many improvements in target offloading using OpenMP and OpenACC directives in Fortran programs. And about OpenMP, the support for version 1.1 is considered practically complete. Have just a few corner cases and issues, but it's practically complete. And now the community is working to complete support for version 2.5. But besides that, some features of later standards are already supported. One example is non-deferred tasks that are already supported. And another milestone that was reached in this area is that now Flang is able to build correctly spec speed 2017, and it's able to run it. It's possible to run it without errors. About a year ago, Flang was being tested mostly with an old Fortran test suite called FCVS, besides the regression and unit tests. But right now, GFortran test suite has been integrated into LLVM test suite, and it's run as part of its CI. And thanks to the efforts of the community, now Flang can pass in around 80% of the GFortran tests. And Yeah, and besides that, Fujitsu and IBM are also working to upstream their test suites, and all this effort has resulted in many bugs being found and fixed, and we have also discovered some missing features that have been implemented during this past year. And now I would like to talk a bit about Flang's performance and some work that has been done in this area recently. There has been some work to improve vectorization in Fortran code with the use of the TSVC test suite. And also the alias analysis pass has been improved. It's using type-based information, and it was greatly improved in the past months. And also, as Carlos mentioned, Flang has introduced a new IR, that is the high-level Fortran IR. And this IR is able to preserve more information from Fortran sources, and this allows for for more opportunities for optimization, and it also provides better debugging information. And of course, there has also been a lot of efforts put into making spec benchmarks run faster when compiled with Flang. And an example is the loop versioning pass that was added, and it improved the performance of runs by a considerable amount, as we can see in this graph that shows the time it takes to run runs with Classic Flang, LLVM Flang, and GFortran. And now we can see that their performances are close. That was not the case some time ago. And in this next slide, we have the results of all Fortran benchmarks of spec, all spec benchmarks that use Fortran. And some interesting things to notice in it is that GFortran is still considerably faster than Flang and Classic Flang for Exchange 2. And it's also considerably faster in Can4 and Photonic. But on the other hand, LLVM Flang is slightly faster in B-Waves, CAC2 BSSN, and WRF. You may notice that there's a missing column here. This is because with Classic Flang, we were getting an error in the middle of the run of the test. So it was omitted in this graph. And the geometric mean of Classic Flang also doesn't include this benchmark. And if we take a look at the geometric means, we can see that that GFortran has the best results, followed by Classic Flang and then by LLVM Flang. And if we take a closer look at the geometric means and compare them, we can see that LLVM Flang currently is less than 7% slower than Classic Flang and less than 20% slower than GFortran. So while there's room for improvement in this area, Flang is not that far behind when compared to other compilers. And another interesting thing is that when we compare it with LLVM Flang 16, we can see that LLVM Flang 18 is 37% faster than it. So it shows good progress in this area in the past year. And now I'll switch back to Carlos.
Okay, so now that we covered what Flang is and a little bit about performance, we'll talk about the bad news. So what's missing from Flang? So one thing that we need to tell you is that it's still not ready for production usage. So we still need to rename the driver from Flang new to Flang in LLVM. So that's depending mostly on the current stage of the GFortran test suite, but also on one important missing feature, which is the procedure pointer support. So once those two things are fixed, or at least the procedure pointer support is implemented and GFortran test suite is mostly passing, then we will rename Flang new to Flang. And there are other known performance issues, especially in spec, that need to be fixed as well, but that's a minor thing. I think the most of the work here is to finish the procedure pointer support. But that's not all bad news, because you can be used by early adopters. So if you're willing to experiment with Flang, you can do it now, because most of the work on the new FIR is done. So the AGL FIR is the new default. We don't have anymore the Flang experiment exec flag. So you don't need that to get the full Flang code output. And as Leandro mentioned before, you can fully build spec CPU 2017. There are some problems with speed, mostly because of OpenMP. It will build entirely, but some of the benchmarks will not run. For the newer standards, we are still missing a few features, like for 2003 core arrays, I think is the most important one. And like I mentioned before, the other standards like 2008 and beyond, the work is still in the very beginning. And we still lack support for OpenMP 2.5 and beyond. I think most of the work in OpenMP now is for 1.1 that is completed. And we still don't have support for OpenACC as well. As with any other open source project, patches are welcome. So if you're willing to get involved and contribute, we have a Slack channel, we have bi-weekly tech calls, we have the discourse board, like any other LLVM project, and all the code is hosted on GitHub inside the LLVM project. So if you download the LLVM repo, you get Flang as well. And the documentation for Flang is also in the LLVM website. And that's all that we had. So any questions? Okay.
It's LLVM, but what's the status of CMake support? Can I point CMake at Flang new and it will just recognize it as LLVM Flang?
In this CMake file?
As in, okay, if I go to cmake.whatever.org, download the pre-built binaries, does it know what LLVM Flang is at this point, or do I have to use a fork of CMake or something?
I don't think so. Yeah, I don't think so.
Okay.
Yeah, when I tried to use Flang new with yeah, the issues I had when I tried to use CMake and Flang new was just the fact that it's named Flang new and not Flang, so CMake was having some serious issues. I think somebody opened a bug. I don't know if it's resolved yet, but mostly if you make the correct aliases and everything else, it works just fine.
I was interested that you mentioned co-arrays. Is there anyone in the LLVM Flang community who's interested in taking that on? I mean, that's a big piece of work.
Core arrays?
Yeah.
There is a work in defining the parallel runtime interface, and it's planned to be used as a basis for the implementation. And they are designing it in such a way that you can use several softwares to implement the runtime of core arrays. So, for example, there is Caffeine, but they want to make it generic. So it's mostly in the API design stage right now.
And do you have any? Are there any of the organizations who are involved in the Flang efforts who are explicitly wanting this? Is this something that one of the companies working on Flang deeply care about?
I know the name of some developers that are working on it, but I'm not sure from which company they are. Or
Okay, fine, no problem. Thank you.
Anyone else? Oh. Thank you.
In my opinion, I think to getting more users using Flang is more important to improve compiler. What effort other than improving or supporting language standards and improving execution performance? What effort other than these things do you think required? So, as David refers to CMakes, so it's very important to prepare the environment to make users use Flang. So, what do you have any idea?
the main missing components. The main missing components in the ecosystem.
I think what Kamasuka is asking is like, how do we get people to actually use this? Because we are missing a bunch of stuff. So what we need to.
Yeah, I saw some people. I think in FreeBSD that were considering adopting Flang GNU as the Fortran compiler, and they were interested in the part of renaming Flang GNU to Flang to make this transition easier. I don't remember.
Yeah, I think one of the things we need better GFortran parity. So there are things that we know that work on GFortran that don't work. I mean, Fujitsu opened a lot of issues on that regard. So, yes.
Could I comment from ARM's perspective on some of the things we're doing there? We're planning on releasing a beta quality version of ARM compiler for Linux later this year using LLVM Flang. And our goal there is for the community to tell us what features they most care about that are missing for the codes that they most care about. We've got a list of features from Recon that we're working on at the moment that should make it into that beta. But yeah, we're planning on putting a beta out and then letting the community play with it and tell us what features are missing that they most care about. And obviously, all of the work we're doing there is in LLVM project, and then we derive that. We use that to derive the commercial compiler.
That's all. Okay. Okay. Thank you.